Hi there. Welcome to Flower Monthly. This is the first Flower Monthly of the year, so welcome and thanks for joining. My name is Nicholas Lane, and we've got a great set of speakers and topics for today. So let me just dive straight in. Our agenda for Flower Monthly this month is going to be as follows. We're going to have a few flower updates as per normal. And then we're going to dive into two invited talks. Both talks are quite distinct in their topics, but I think they're going to appeal to a lot of you out there. And the first of these talks is going to be given by Professor Kang-Yoon Lee, who leads the Cognitive Computing Lab in Gaochang University. And he and his team have been developing a FedOps platform that runs on top of Flower. It is a design partnership they've been running with them for quite a while now. They're going to tell us all about the progress they've made and how users of the Flower community could start to adopt and benefit from their wonderful work. After that, we're going to hear another talk that's more of a research sort of flavor given by both Álvaro and Judith from the Spanish National Research Council. And they're going to be talking to us about some exciting new applications of federated learning that they've been exploring. In particular, there's an aspect related to water quality, but I believe they're going to be looking at a number of sort of environmentally orientated uses of federated learning. So that's also wonderful stuff. Before we get to those two talks, let's review what's happened for Flower over the last month. And so naturally, as this is the first meeting of the year, it's natural that we'd say happy holidays and happy new year to all of the people who are joining in and listening later on YouTube. It's been a wonderful year. We reflect back about all the milestones that the community has achieved. It's really, really wonderful and impressive how far we've pushed federated learning in the last 12 months. And it makes me really optimistic about what we can achieve in the 12 months that come ahead of us. So thank you again for everyone who's contributed in 2023. Another announcement we'd like to make is that Flower Summit 2024 is fast approaching, in fact. It's going to happen in London. So in the past editions, we've either been exclusively online, or last year we had a hybrid format where we were based in Cambridge and online. This year, Flower Summit is going to happen in March. It's going to have this hybrid nature, meaning that you can join in and participate fully online. But for those of you who can attend physically, we're going to move from Cambridge to London. That's going to enable us to have a larger venue, have sort of most closer proximity to a lot of other universities and AI labs, and hopefully be a little bit easier for travel. So the link is available. The URL you can see there to the website for the Flower Summit 2024 is up. We have registration pages for those who want to propose a talk or those who just want to simply attend. And it will be in London, but we haven't quite finalized the date. So we've got two dates that we're examining in terms of the venues that are available. And London's a sort of busy place, so we haven't quite nailed down that precise date yet. But we wanted to give you an early preview of the event as soon as we knew the location and the month. And I expect to give you more refinements about the exact location and dates very soon. But mark it in your calendar. It's going to happen in March in London. Really exciting stuff. I can also review a couple of things that we've released in the last month. And so one of these is quite interesting. We call it Flower Visuals. You can access the material from the URL that you see here. And the whole idea is that if you're giving a talk on federated learning, perhaps if you're wanting to refer to Flower or many of the topics in this general area, it's often useful to have nice, ready-to-use visual artifacts. And so we've released a lot of the style, the graphics, the colors, and so on that we often use in the presentations, such as this one. And we've made it available to the community to use. And so if you happen to be doing a talk on federated learning and you need certain graphics that can illustrate these concepts, feel free to visit this URL and adopt some of the things that you'll see us using constantly throughout our material. So we hope that it is useful. Another thing that we're hoping can help the community is that we're very strong on outreach. And some of you might recall last year, around September, October, we had an event called Flower Around the World. And in this event, we, within a 24-hour period, we provided a number of tutorials and hands-on how-to guides through a video stream, but where the unique characteristic was that we delivered this material in various languages that correspond to pockets of the flower community. And we also scheduled the timing of this event at different times throughout the day, so it would align well with those different time zones. As a further effort to reach out to those of you who speak different languages and are based in different areas of the world, we've moved beyond just having our visual material on YouTube to a popular outlet called Bilibili. And so Bilibili is one of the largest YouTube-like video streaming communities in China. And it's we've started to release material on our own official Bilibili account for Flower. I was looking it up just a few moments ago that Bilibili has more than 330 million active users monthly. And so now those folks who are using this Bilibili service can look at the flower material, and we'll be making custom material in the Chinese language using translations, as you see here with our first video release moving forward. And we'll also be considering other distribution methods like Bilibili, but in other regions as we sort of expand outward. So I think this is a really wonderful effort that we've started in the last month with our first Bilibili video. And finally, I want to highlight that we're hiring. You would have seen a number of announcements on social media in the past 30 days of various kinds of positions that we currently have open. We've set up a more comprehensive careers page from our website and listed a number of these roles that we're looking to hire. Flower is expanding as a community, and it is expanding in terms of its ecosystem and open source tooling. And so naturally, we need people to help us maintain, build out, and reach out into the community as we always have done. So if you're interested in changing the way the world thinks about machine learning and making federated learning and collaborative methods the default and mainstream choice by all of machine learning, please join us. You can find all the different roles that we currently have available at the URL that you see on this webpage. And we'd love to hear from you. We've been hearing from some tremendously talented people already, but the world's a big place. We'd love to hear from even more of those who are passionate about this mission. So with that, let's now transition from the Flower announcements for the month to our first talk. And so this is going to be, as I mentioned earlier, a presentation by one of our core design partners. And so if you're interested in becoming a design partner, please go to the Flower website and look at our pilot program set of pages. It details an application process whereby Flower and different organizations can work together to accelerate our mission and develop new methods or new applications on the Flower platform. And so one of our early adopters and participants in this program has been Kang-Yoon Lee, Professor Kang-Yoon Lee, who leads the Cognitive Computing Lab in Korea at Gachon University. And he has brought a number of his team members along today to tell us all about a platform they've been developing that focuses on federated learning management of what is often a complicated marriage between machine learning and distributed systems. And so I'm delighted to see the work they've been doing, and I'm really happy to see them sharing their progress with us today. So I'll hand over to Kang-Yoon so he can start their presentation.
Okay, thank you. So I'm sharing. Okay, thanks for giving us our monthly presentation and also the kind explanation about the Gachon University's design partner operations. So we are developing FedOps on top of Flower framework, and today I will deliver the FedOps the tutorials and our communities. So I will explain FedOps, the overview I'll cover, and FedOps silo and FedOps mobile. The tutorial will be delivered today. Yonggyum and Paot, who are master students, will join to deliver tutorial session as a hands-on lab. Through this session, it makes you to learn FedOps with your AI model and data. So the FedOps motivate to operate and manage federated learning environments such as machine learning MLOps of AI model. FedOps has three key questions. Question one is how can the machine learning project be easily applied to distributed federated learning environment? Question two, there are numerous clients. How can we distribute models and data on federated learning environment? And question three, how can you manage and monitor the lifecycle of client and server for federated learning operations? Right side, the picture is an overview of FedOps. We expanded the existing MLOps to easily apply federated learning to machine learning project. The baseline model created through MLOps is deployed and executed to numerous clients so that federated learning can be performed by connecting to the server. FedOps supports that local global models can continuously manage the version. And FedOps can manage and monitor the federated learning lifecycle by tracking the logs of clients and server for federated learning operations. So to solve these three questions, we need to provide FedOps with 5 core functions. First, FL Scalize. The meaning of FL Scalize is that the data and models can easily apply to a federated learning environment. FL Scalize utilize Flower framework to scalize FL client and server. FedOps is configured by applying to the Flower code structures. Second, FedOps has client-server manager functions. Managers continuously manage online training status of client and servers. The third one is CE and CS function to improve the performance of federated learning. Contribution evaluation and client selection are performed according to the client's performance. We will consider many algorithms for client selections. Fourth, CI/CD/CFL is connected to code repo to deploy code to numerous clients and servers. and perform federated learning continuously and periodically. We use GitHub for code repository. Fifth, FedOps has client and server monitoring dashboard for lifecycle management of federated learning client and server. We are using 1DB, ELK, and FedOps Web. And it shows FedOps open source community as same as Flower community. There are web links for FedOps main site, GitHub, and document. So please report all this information. You can clone a Git and learn as your own purpose. Okay, now we will have FedOps silo and mobile tutorial session to show how you can utilize Flower and FedOps. Yonghyun, will you explain more about FedOps community site and lead FedOps silo tutorial hands-on lab?
Yes, Professor. Hello, my name is Yonghyun, and in CCL, I develop FedOps Web and FedOps Silo site. Okay, let me explain FedOps community. First of all, our FedOps Web. This is our FedOps Web main page, and in here you can create and manage the task for conducting federated learning like this on this page. And FedOps document. In here we describe FedOps architecture and user guide and our libraries function. So if you have any more detailed information, please watch this our documentation and our FedOps GitHub. Our FedOps are open for everyone, so you can view and modify the source code, and it also provides a link can be accessed with Slack and LinkedIn and our CCL site. So you can access the communities you want. And also we present at Flower Summit 2023, and it is posted on the YouTube. So if you want to watch it to our presentation, please use this link and watch our presentation. And last one, we make the Slack for FedOps. So if you have any questions or improvements for FedOps, please tell us through Slack and we will solve to you. Let's start the silo tutorial now. The FedOps silo consists of 5 steps. The first effort test create and measurement step is to create FedOps baseline code and create the data and models for federated learning. And second, register FL client. Client just bring and execute the previously written baseline code for your FL test. And third, select client and run FL test. In here, you can select clients who will participate in the federated learning and start the federated learning in this step. And fourth step is check the client log during the federated learning. You can check the client learning situation and the server status. And the last step is monitor the global model of task. It is when the federated learning is ended. And you can check the client, and also you can download your the global model on your FL test. To perform the first step, we should go to our FedOps main page and click this FedOps silo. Then you can download our FedOps silo baseline code. You just bring this to your own development environment like this. You just modify models.py and data preparation.py. The others are not modified. The others not used. The others just run as automatically, so you don't need to modify them. In the model subfile, put your model you want to run in here. I set MNIST classifier as a model, and I said how to train and how to test. And in data preparation file, you just coding coding for your data, like pre-processing or split into train and test dataset. And in here, I use the MNIST data and just split into test and train. After that, setting the configure file. In here, you select your models, which model is using library. We are using PyTorch, and model's name and dataset name. And in here, this is for the server's configuration. We set epochs as 3. Batch size is 100-28, and our ROM round are set 3. And you can set also clients per round. And in here, you just set server strategy. Are we using bad averaging as a strategy? You finish, modify the configuration, and just push to your own GitHub links. I push the baseline code to my Git repository, and after that, we create the FR task. In here, make the task's name. I say flower monthly silo, and select client type and set the description about the task. And in here, a server Git repository address is your Git repository. Your server baseline code is store the repository like this. Copy your link and paste it here. And click the create. If you see this page, the task is successfully created. And the next step, client register page. Each client cloning this baseline code to each client and set here task ID to your task name as you created. In here, my task ID is flower monthly silo. So copy task ID and paste it here. This is for the client to notify to server. I want to participate in this task. So I set the task name as a task ID, and client just run Python file client main.py and just run client main.py. Then client main will be communicate with FL server for Federated running, and client manager will communicate the server with the FL server status, and client manager notify to server or client status. So back to our FedOps web, then we can watch which client is ready for Federated running. So you just select your client and click FL start. Then Federated running is ready for start. And until it is running, I will show you the FL test our silo tutorials results, monitoring, and global model. Go to your task as you want and go monitoring tab. In here, you can see the global model performance like this. And also you can see each client's performance and resource usage. And also change the model's version. So you can see each version's global models too, and each version's clients too. And in global model tab, you can download each versions of global model, so you can using the global model or you want. And as a final, we can also check the client log. In client manager, show the health check with client and server. It said April is ready for us because it was because our client is running in this time. And client main, the pie show the log of the client's running status and performance like here. This is the end of silo tutorial, and I will turn over to Hahoud for our FedOps mobile tutorial. Hahoud, please tell us your tutorial.
Hello everyone, is it visible?
Yes.
Yes, looks good.
So I'm Farhud, I'm a member of Social Laboratory, and currently I'm developing FedOps mobile part. And today I'm going to give you FedOps mobile tutorial. So let's start from first FedOps mobile architecture and overall overview. So FedOps mobile based on iOS and Android platforms on top of Flutter. So Flutter is open source SDK provided by Google. So with Flutter, we can develop multi-platform applications with same code base. So in FedOps, also we used native platform functions using event channels and method channels. We can call Android and iOS on training features, on device training features using these methods. We can call one-time call functions using method channel, and we can listen continuously methods using event channel. So I will move to today's tutorial. For this demo, we used Cypher 10 dataset for Android, and for iOS, we used MNIST. So first, you have to create your model using TensorFlow and convert to TensorFlow Lite format using for Android, and for iOS, you have to create your model using Core ML create app using Xcode. And once you create your models and convert, you can see your core TF Lite model description like this in this picture, input details and output details. And for core ML model, you can open using Xcode and see the descriptions as in the picture. So to use FedOps mobile, you have to clone FedOps mobile from here and open FedOps mobile in your Android Studio. And to implement your model, open Android folder in the project and open app. And here we have build Gradle file, and put your model URL at here and data URL to here. Your URL should be downloadable link, just download when you click. And for the iOS, open the iOS folder, put your model and dataset inside the scenarios folder. In here, like MNIST, and these are train and test datasets. And this is our core ML model. So to develop, first you have to implement API connection parts, because we get our server link ports through the API from our server. So it's just basic things. I'm not going to explain this. For your development page, you have to implement download dataset buttons and connect server and start training buttons. You have to connect these buttons to UI, and once you run this demo, you will see this view, and then you have to create your task from our FedOps website. To create, login to FedOps website and click the create button and enter your task name. I'm going to enter it as tutorial monthly. And for this tutorial, I'm going to show Android. And for description, and here you have to input your Git repository link for your server. For my server repository link, I'm using this repo. You can clone and use in your Git repository. And first, you have to edit this file for your configuration. In our configuration, I'm using Android, and we have 5 number of efforts, and batch size is 10, and our number of rounds is 3, and at least one client should have for each round. I will copy the link, enter here, and I will create my task, and enter here your task name. So our client is registered. You can see here each client's identifier in these numbers, and in mobile it will be here. And we start our server for this client. Usually it takes 1 to 2 minutes for its running. So I already created other task and it's already running. So we don't need to wait for this task. So I will use this one for rest of the tutorial. The task name was demo task. Yeah, so our device is registered here. So it's already started and running. Then we can get our server port by entering the task name again. So server creates this port for our task, and this is our task ID. So we start loading the dataset. In console, you can see our client starts loading dataset, and it's already finished. And we can connect. So our client is connected to server, and we can start training. So our client is already started, and you can see here current round and epoch. After each epoch, you can see accuracy loss. And in this progress indicator, you can see how much of the overall progress is done. And in this chart, you can see your accuracy and losses as chart format. And in console, you can see other console messages. For implementing machine learning models in mobile, it's really difficult task. We implementing other custom data sets and models. Upcoming months, we will show how to implement and create custom models for mobiles, and we will provide other public datasets to choose while you're training. Yeah, so our training is finished, 3 rounds and 5 epochs. Here you can see your client's overall results. And for platform, for now, monitoring your clients from web is not possible, but we also developing this part. In upcoming versions, we will provide monitoring clients in FedOps platform and see global models from here. But for now, only monitoring client in mobile side is possible. So that's all for mobile tutorial. So I will move to Professor Lee. He will cover up the rest of the presentation.
Okay. So thanks for the presentations. So we deliver the FedOps Silo and FedOps Mobile, how we can easily build federated learning environment on top of Flower. So now we announce special program to support as user trial program in January. So if we use FedOps, just you can fill out the information as on the right side and email us. Then FedOps team will support you with your federated learning scenarios. So let's make the many use cases. And in addition, we are currently creating FedOps industry fact as a reference use cases. So it would be a good reference to apply your model to FedOps in the world. So it is end of the presentation. Thanks for listening. I would appreciate your questions and suggestions on FedOps and these tutorials.
Thank you for the 3 presentations. They were like really informative, and I think they give the community a snapshot as to what the system is able to offer. I'll take a look to see if there's any questions. Feel free, anyone who wants to ask, they can use the Zoom or the Slack or anything. But as the talks were going, I was collecting a few of the questions that came in. And the first of these was, I guess you've answered it at the end there, but one of the questions that took my attention was, they said, can they use it today? I noticed at the end you said there was a sign-up process. Could you tell us a little bit more? If somebody wants to use it today, should they just contact you using the method you described?
Yes, Yonggyum, will you explain about how we sign on to FedOps site?
Oh yeah, in now we block for the register the account. So if you want to make an account and using our Fedora, please send the email from like appropriate set. Then we will make the account and send back to the account we create. So yeah, in this time, please come our FedOps participate.
I see, and so it can be any application domain. So at the end there was hospitals mentioned, but you're open to any type of application that someone wants to use the system for.
Actually, the AI model and data, if they bring us, then we can build up on FedOps environment.
Great. So it could be any application domain. Then it sounds like.
Yes.
Anyone? Yeah. Perfect. Very good. Another question somebody had was what is the biggest thing that you think becomes easier with the system? I noticed there was web GUI things, there was monitoring of clients and so on. Do you want to perhaps, I think an interpretation of the question would be, could you pick out what type of usage is the thing that people might get the biggest benefit from?
Yeah, I think our FedOps biggest approach is it's easily implement to real world. Uh, we just only make the baseline code for server and client, and server and client just running that baseline code at once, so you did easily communicate with a real device and server. And our in our industry pack, we are planning about 100 hospitals emergency rooms as a client. So we are testing it.
Sounds amazing. Sounds like 100 hospitals would be incredibly impressive deployment. I guess another question relates to limitations. Are there any specific limitations that you want to point out to people at this time? I understand you're just developing it and onboarding some initial users. Are there any particular limits, maybe with the type of model, or I don't know, anything at all you want to highlight?
In this time, actually, our server resource limitation. So we maximum 40 FL server will run at same time. So we get the participate for this limitation. And the next limitation is at this time we are more good at only classification models, and the others are not well worked in now. And also we just only see the client logs, not server's logs, because so we develop this part for the in FedOps web. Users can watch the server's log and how server running going and how server status is, and any other problem is occurred in server to watch the user.
I see. See, you mentioned a limit of 40. Is that 40 aggregation servers running,
Yes,
or is that
aggregation
40?
server.
Oh, okay, 40 aggregation servers. So that would, roughly correspond to 40 different federations then, depending on what the topology.
Yeah.
I see. Okay, cool. I guess my question would be, what do you see happening next? Like, what does the next, say, 2 months look like for this really strong application and system?
Oh, within 2 months. Okay, so next our consideration is we need to have more the client selection algorithms, and also the integrate with the public cloud models. That's the primary agenda, and we need to get a requirement, and then we can make further.
I see. Great. Great. Well, thank you so much. I'm super impressed by what you've been able to accomplish, and we're delighted to have helped you in a very small way wherever needed. But it's really amazing what your team has accomplished here, and I hope that many people from the community utilize these capabilities. Wonderful stuff. Thank you for the contribution.
Thank you for the opportunity.
Great. Well, I will share my screen again, and we can move on to our next invited talk. So our next invited speaker, both of them come from the Spanish National Research Council. I'm joined here by Álvaro and Judith, and they're going to be giving a talk on the use of Flower and more broadly federated learning within the area of the European Open Science Cloud, where there's a variety of applications and scenarios that are all very important. And one of the ones that caught my attention, because I haven't seen so many applications of its type, was in the direction of water quality. And so I'll hand over to Álvaro and Judith to tell us all about it. But I really love the idea of federated learning and in particular Flower being used to develop these applications that assist how we can care for the environment better. So over to Álvaro.
Hello, everybody. I hope you can see my screen. So,
Yeah.
and that you can hear me okay.
Yeah.
So, thank you, Nick, for inviting us to this event. We would like to present here how we are dealing with federated learning in the context of the European Open Science Cloud, explaining a little bit of introduction of what this EOSC, European Open Science Cloud is, and then I will pass the floor to Judith so that she can explain the specific use case you just mentioned. So first of all, I would like to briefly present in 2 or 3 slides what is this European Open Science Cloud, because this is where the context of our work is. So these slides are not from me; these are from the EOS Focus European project that is coordinating and supporting all the actions within the European Open Science Cloud. The vision of the EOS. This is an initiative that is being created by the European Commission and the European Union in order to create what they call the European web of fair data and services for research. By fair data, we mean here research data that is easy to find, access, interoperate, and reuse. This is what it stands for fair: findable, accessible, interoperable, and reusable data. In order to make the research outputs available for all scientific disciplines and for all researchers in Europe and beyond. Why? Because there is a lot of potential that has not yet been unlocked in Europe. This is the statement from the association and the Commission. Who is this European Open Science Cloud? This is open for researchers and innovators that are willing to follow the open science principles. What it is not a single cloud infrastructure. The word cloud here is a bit convoluted. It is a system of systems that will allow researchers to join other infrastructures, other services, bring data together, and provide added value on those data, always with this open science paradigm in mind. This is the framework where our project is being developed. And let me introduce in a nutshell what is our project. Our project is called AI for EOS, which stands for Artificial Intelligence for the European Open Science Cloud. It is a research and innovation action from the European Commission that is trying to build a platform for distributed, federated, composite learning AI in this context of the European Open Science Cloud. We are 7 academic partners, some small enterprises, 1 non-profit organization. Our objectives, I will summarize very briefly here, as I already introduced, are to provide these feature-rich services in the EOS focusing on the development of AI applications, support for building AI systems on distributed datasets, and here is where federated learning makes a point in our proposal, to provide developers with services to compose AI modules, enabling more complex data-driven AI applications. Our 4th objective is to create an exchange of open AI models that are focused on science and exploiting resources of European infrastructures, with the final goal of extending the service offer of the European Open Science Cloud with a focus on AI, machine learning developers and data scientists. We come from a previous set of initiatives where we started to exploit this idea. We developed some years ago the Deep Hybrid Data Cloud project that provided access to European researchers, transparent access to accelerators that were already available in the distributed pan-European clouds that exist, like the EGI Federated Cloud, for example, and beyond. And we are now evolving this software in order to provide this set of advanced features where we think that federated learning is one of the central points for the next years. This is our very high-level architecture. We are leveraging mostly open source components that are being integrated in order to create what we call the AI for EOS platform. At the bottom, we have resources coming from cloud infrastructures provided by commercial providers or by open source projects like OpenStack. We are federating all of them in a platform like using HashiCorp Nomad. And on top of this HashiCorp Nomad, we are deploying Flower in order to provide scientists with this access to federated learning systems easily. In order to do so, we are developing obviously some tools like our own API and the dashboard that will be demonstrated by Judith later on. These are our features regarding the platform. We have completed the first year of the project in September this year. We are already providing a federated learning server for our users, and we are working towards the integration with different authentication and authorization modules that will extend Flower to provide fine-grained access to the resources. This is how our federated learning scenario looks like. We are providing the users of the AI for EOS platform with this collaborative and decentralized approach to build machine learning models by exploiting Flower. This has been the tool of our choice due to the simplicity of the implementation and the easiness of the deployment. It is not convoluted, it goes straight to the point, and it fits perfectly in our architecture. We are providing users with the ability to manage the experiments through the dashboard, and we allow users to participate within the platform so that different trainings can be executed on top of our resources or externally, which is the most important scenario for federated learning. So everybody can join an experiment with authentication in order to contribute to the training of the overall model. Some common features that are related with this: we are working on implementing authentication modules for Flower. We are working right now with bidder tokens. We are extending it to use some secret management systems like HashiCorp Vault. Profiting from the architecture design that we have done for Flower, we are also working in other distributed training schemes like split learning or parallel training with Horobot or the TensorFlow parameter server. And we are working towards more updated features for this, the training of the experiments. This is all from my side as an introduction. So I will open the floor to Judith, that will continue with the specific use case of our project and how we are implementing the federated learning in the project. So Judith, the floor is yours.
Thank you very much, Álvaro, and thank you, Nick, and all your team for inviting us today. I'm going to share my screen, so now you should be able to see my screen.
Yes, looks good.
Okay, so well, I'm going to start by talking a little bit about federated learning and how have we used Flower in the i4 us project for performing a federated learning training. So here we have a screenshot of the dashboard of the AI for use platform in which we can see different modules. So for example, if we see here the image classifier, this is a module that we can deploy in order to train an image classifier with our own dataset, but it comes pre-trained using ImageNet. We can create different modules or from scratch, we can create our own deployments, but we also have these tools here in which we can find the federated learning server, which has been created using Flower. So if we go to the configuration of this federated learning server within the platform, within this dashboard, we can see some general configuration regarding the password that we will need to use to access to the interface, the name of the deployment, and so on. Some configuration regarding the hardware configuration, and the most important part in this case is the federated configuration, in which the user just needs to include the number of rounds for training the federated learning schema, the minimal number of clients that will be needed for starting the federated learning training, the evaluation metric that will be used. In this case, as an example, we have included here the accuracy, but we can even include more than one metric. For example, in some cases, we may need to use the mean square error together with the mean absolute error. So we can include more than one. And then last but not least, we have the federated aggregation strategy. Here we have 5 predefined aggregation strategy that are implemented in Flower. So this is the quite simple interface that the user will see before submitting the module. So when we submit this federated learning server, we will have a quite intuitive interface in which we have this README here, in which we can see how we launch this federated learning server, which is quite simple. In this case, we just need to run Python 3 server.py because we don't need to do these steps here because we have used the dashboard. And how can we get started? So if we go to the code of server.py, in which we have the Flower server, we can see that here we are reading the variables that has been introduced by the user, the number of rounds, the metrics, the number of minimal clients, and the strategy introduced. And then we can just have here the Flower server in which we started, and then the different clients can connect to it. In order to connect with the server, the clients that, as Álvaro has already mentioned, can be deployed, for example, locally in our own computers, but also in external cloud providers, or even in another AI for use deployment. They just need to introduce the deployment ID in which we have deployed the federated learning server. This is explained here in the getting started. We can see that each client of the schema must enter the endpoint following this schema here, and then the clients will be connecting to the server. So then the users just need to run this file, this server, and then start the different clients and connect them to the server. So let's take a look with a first client in which we just run the code in which we have the client. So following the Flower guidelines, we have created a class called client number 1, for example, in which we have introduced the different functions for training this federated client and using the client NumPy client of the Flower library. So we just connect here this first client. We can see the connection is ready. This from the client side, and from the server side, which will be deployed in the A4S platform, we will receive this message, which we are all used to, but the federated learning process is starting. So now, if we introduce the second client, we will be able to see from the A4S part, we will see this from the server side, the evolution of the process in which the federated learning is starting, and it starts when it receives 2 clients out of 4. So then we have the first round with 0 failures, we can evaluate, and so on. So this is how we can perform a federated training in just 1 minute, let's say. using the A4S platform in a quite intuitive way for the user, because we are using the interface that I have shown you previously, in which we just need to write, okay, I want this metric, I want this number of clients and this number of rounds. So it's quite easy for the user to deploy the server and then to connect the different clients to that server. So that's how we can start a federated learning in the platform. Now I'm going to move to this specific use case that we want to talk about, which is already presented in this paper here. Is about environmental sciences, but about water quality in particular. So first, let's start by mentioning that, as we all know, fresh water is an essential resource for life, and we need to maintain it properly. So it's quite important to focus in techniques such as monitoring, which can help us to do so. So in this case, we are going to focus on monitoring the concentration of some pigments that we can find in some water bodies, like chlorophyll. In this case, this is a key task to contribute to water conservation, to the water bodies conservation. Nowadays, with the existing sensor technology that we have, it's quite difficult to have measures in real time with enough frequency in order to be sure that we are properly assessing the risk management of this kind of blooms that can arise due to a lot of amount of concentration of chlorophyll. So in order to avoid these kind of problems, we can use deep learning models, and in this work we are also using federated learning, not only deep learning. So in this case, for this data-driven application using deep learning, we are going to use 3 hydrophysical features and 3 meteorological features in order to be able to estimate the concentration of chlorophyll in 2 rivers, in 2 tributaries of River Thames. So we are going to use 3 learning paradigms. We are going to compare the 3 approaches that normally and naturally arise in this case, which are individual learning, centralized learning, and federated learning. In this case, we have 2 rivers. The first one is Emborne, which is a rural environment, and the second one is the river Dicat, which comes from a urbanized catchment. So there are quite different conditions. The rivers have quite different conditions because of their area. So let's take a look to the data processing that we have carried out and the features that we have analyzed and that we are using in our deep learning model. First, it's important to highlight that all the data that we have used in this study are openly available. First, we have data containing information about the 2 rivers, River Emborne and River Dicat, which are obtained from the Environmental Information Data Center of the Center of Ecology and Hydrology, belonging to the United Kingdom's Natural Environment Research Council. And we have selected just 3 hydrophysical features, which are the water temperature, the pH, and the electrical conductivity. There were a lot of features in this database. There are others such as the oxygen dissolved and the flow and other features which are also quite important for water quality monitoring. But in this case, we have decided to only use these 3 because are the easiest to collect, and the sensor that collect them are the most common ones and the easiest ones. So it's quite common to have these features in other future use cases. So that's why we decided to use these 3. In addition, we think about introducing other features that are openly available that could help to improve the study. So we decided to use meteorological variables, such as the global irradiance, the air temperature at 2 meters above the ground, and the one displayed at 10 meters above the ground. Then we need to detect and to remove some outliers that arise in these cases. So in order to do so, we use the growth rate and the Takis test. We can see here in this time series how can we detect the different outliers and remove them. We have used the growth rate in order to not remove values that could seem anomalous but are not outliers, because we can have some natural phenomena that cause some peaks, for example, this or this, but may not be outliers. So we take special attention to that. Here we have the features that we have analyzed, comparing their values and their distribution in the cases of Emborne and the cases of Dicat for the train split and for the test split. You can see that there are features that are quite different. For example, the electrical conductivity, the distribution in the two rivers are quite different, and there are others that are more similar, such as the temperature and, of course, the three meteorological ones, which are almost the same distribution. So I talked previously about the three approaches that we are going to use in this study. First, the individual learning. I think that is the most intuitive one we can think about because we have two rivers. So let's train two models, the same model for the two rivers, just in order to be able to compare the results of the three approaches, but two models, first for the river the Cat and the other for the river Emborne. Then we evaluate them individually in each river and train each model during 500 epochs. In the case of decentralized learning, I think that it's also quite intuitive to apply this approach because we have two rivers that are quite different according to their natural state, because one is more rural and the other is a urban one. But it's interesting to try to centralize all the data together and try to train the model and see how good is the generalization ability of such model. So we do that. So it's partition for both river were joined together, and then we test individually in each river. So we train during 500 epochs again. And last, we have federated learning. Here it's clear that we have two potential clients, which are each of the two rivers that we have. So we consider three cases here. First, training during 10 epochs, then during 50 epochs, and finally during 100 epochs. Associated with the number of epochs, we associate a maximum number of rounds of the federated learning schema in order to be able to compare the three approaches properly. So, in the case of 10 epochs, we train the model a maximum of 15 rounds, and so on, as you can see here. Then we optimize the number of rounds of the schema according to the mean square error that we obtain both from the train and the validation set that we have for the two different rivers individually. And we can see here in these two tables the results that we get. We could expect that the best results will be obtained for the individual approach because the two rivers were quite different. But here we can see that in the case of the Cat, the best results for train were obtained with the federated learning approach, not for test, but are more balanced, let's say, because here the error for train with the individual approach is bigger than the one obtained with the federated learning, and we are reducing a little bit the error for test. Same happens here. We can see that we get a slow error for train with the individual approach, but the error for test is better with the federated learning one. So it's quite difficult to find a balance between train and test because of the condition of the river. There was special issues in the test which were quite difficult to predict just seeing the train, but we can see the potential of the federated learning application. And in the same line, in the second table, we have the results obtained with the 6 features, because we tested first only using the 3 hydrophysical features, and then we introduced the 3 meteorological ones in order to see if we can see some improvements. I think that we are going to see it better by taking a look to the time series and the predictions that we get. Here we have the prediction for Emborne for the test set. We have in green the observed values, and in purple we have the predicted one with federated learning. We can see that we can capture this first peak here well with the federated learning approach. It's a little bit better with the individual one, but not with the centralized approach. And same happens here, in which we can see that the individual and the federated learning are quite similar, but the centralized one is quite worse. And same happens in the intermediate parts of the time series in which we don't have peaks. And here for the Cat, we have again that this first peak is well captured by all the 3 approaches. In this case, we have in blue the federated learning approach for the Cat. This other peak is also well captured by the federated and individual approaches, but not for the centralized, which performs worse here. And this other peak is only well captured by the individual approach because it's quite anomalous. We have taken a look to the features that we had in that moment, and it's a quite anomalous value. So that's why even the individual model is not taking it so well. In this case, these models have been trained with data capture each hour. But what happens if we have less number of data? For example, if data is just captured each 24 hours or even each 1 week, we just take one data each week. It can be, we can think that this is quite anomalous, but it's not, because in some cases there is one person who goes to the water body and takes the measure from the sensor. So it's quite common to have a lower amount of data. So we decide to test what happened in these data reduction scenarios. We are simulating that we have less data for training in order to see what happened in these cases. Because if we think about the individual approach with a lower amount of data, we will not probably use it, and we will think, okay, I have a lower amount of data, maybe I will need to centralize it. What we have seen is that in these cases, the federated learning is better than the centralized approach in a lot of scenarios, because I have just shown these two. In the paper, we show 3 cases. And we can see, for example, here in each 24 hours, that the federated learning approach is capturing quite well this peak here, not the centralized one. And here, all the 3 approaches are capturing this peak. In this other case of the cat, this first peak is well captured by the 3, a little bit better for the federated one. And again, this anomalous peak is not captured by none of the approaches. And this one is just captured by the federated learning approach. So, in order to conclude, with this study, we have seen that the machine learning and deep learning techniques can be quite useful for predicting the chlorophyll concentration using only hydrophysical features, but also when we add the meteorological ones. As we could expect, when we have a lot of data, the individual learning normally provides better results for training. But when we combine the information from the 2 rivers, which are quite different information, quite different values for the different features, the federated learning paradigms can result in a higher generalization ability, which can be seen for Enborn especially and for the test split of such river. Also, just to conclude, these results show that the federated learning approach has quite interesting applicability, especially compared with the centralized one, especially when we focus on cases when privacy or technical conditions require to use these kind of approaches. For example, when we have a low amount of data and we cannot use the individual approach, when we have little data available, or when we have privacy issues that do not allow us to centralize the data altogether in the same place. So if you want to check the full paper in detail, we have included here the link and the code that you can scan it and check it and take a look to the work. So that's all for my side. So if you have any question, comment, thank you very much.
Thank you for the wonderful talk. It's really an interesting platform and series of applications that we just heard about. I've gathered up a few questions as you were going on that people asked, but I noticed that Javier had a couple he wanted to ask himself. So over to Javier first.
Yes. Thank you, Nick. Thank you, Judith and Álvaro. I think this was a really interesting use case for FL. And I have, I think 3 questions, but I'll start with 2, just in case somebody else wants to ask something. For the hydrophysical and meteorological features you were describing, Judith, so you had 2 clients because you have 2 rivers, but I was wondering if the data is gathered at different points along the river, and if that's the case, would it make sense to have 1 client for each, place where the data is collected, where the chlorophyll is measured, maybe? And in this case, do you think it will work better?
In this case, all the data, for example, for Enborn, there were only 1 point of capturing the data, so there's no problem for that part, and the same for the cat. So we have only two clients for that reason, yeah. And we have been working in another work in which we have a different water body. It was not a river, and there were points of measuring in different places, but we have not already tested. And again, it happens that we need to test what happened first in the train split, in the test split, because the differences are huge. In this case, we have seen that even due to natural phenomena, there are quite different conditions for train and for test. So I cannot say if this will be working properly in other situations, because they are quite different.
Okay, yeah, makes sense.
I think
If I
Álvaro
may-
wants to say something.
Yes, I just want to add a couple of things. As Judith said, for the river and the airborne, for this specific case, there were only 2 sampling places, let's say 2 sampling points. So that's why we had only two clients. But the point with this kind of data sets is that they are not so easily findable. Also, when you go, for example, with some companies or with some research groups that are using the same data, it is difficult because it is really time consuming. I mean, in order to have a large data set, maybe you need a 5-year, 10-year campaign. So data sets are not so easily findable. We are now in the process of checking another data set that we have found, that we got access to, that contains information from rivers from France, that contains historical campaigns for much more sampling stations and much more with a larger time frame. So in this case, we will check, obviously, if considering each of the sampling stations as a client will make sense and will improve the predictions, but not for this specific case, because we only had two sampling points, let's say.
Yeah, I think it will be quite interesting to see, if maybe having more sampling stations along the river could help mitigate the problems of, one river is so different from the other because where it flows, for example. Okay, moving to my next question. Could you talk a bit about the type of model, like the type of architecture you use for this particular set of rivers? And do you think it is lightweight enough, for example, to run directly on the hardware that this sampling station might have, which might be very constrained, for example?
In this case, as we just wanted to compare the individual centralized and federated learning approaches and just have an idea of how is working each approach, we perform a quite simple convolutional neural network. I have here the number of layers, but I think that it was like 10 layers, something like that. So probably it could be run in different devices because it's not quite complicated. It's a quite simple model, but it's because our objective was not to create the best model for this objective, but the model that we can use to compare that works well both for Reborn and for the cat, and that we can compare in the individual centralized and federated learning approaches in the same conditions, let's say.
Yeah, I think makes sense. Okay, cool. I think those were my 2 questions. Thank you very much.
Thank you very much.
Sorry, I just forgot to unmute. I had a couple of questions that came in. They came in 2 basic varieties. One was related to the platform, and the other was related to the actual application research we heard at the end. Just about the platform, it seems fascinating. I can kind of see what they're getting at. And so the tenor of the question is, can anyone use this platform, or is it only for scientists, or is it only for people in this research grant? Who can use it?
Well, the point now is that it is closed for the collaboration, basically because we are still developing it. But we are, the platform is developed and is ready to be used, but we are adding these new features. Therefore, we are, for the moment, only using it within our platform. So we have 3 different use cases, apart from this one that we just showed, that are officially driving the evolution of the platform. But we are planning the first release and open it to the public in, if I'm not mistaken, by the beginning of March. So we will have a fair release of the platform. We will open it through an open call for specific use cases. I mean, we cannot open it widely to the public, basically because of resources, not because of anything else, hardware resources. And then the point is that, I mean, the European Open Science Cloud is focused on supporting researchers and innovators, regardless of if they have a grant, if they have funding or not. But this is still the funding model and the access model within the EOSC is still being is something that is being developed. But for example, we have another deployment of the platform that was done in parallel with the AI4EOS platform, which is called the iMagine platform, which is done by a sister project that is tailoring our platform with our software for the exploitation of AI techniques to analyze images that are related with ocean and aquatic research. So there, for example, there are different use cases, around 10 use cases, if I'm not mistaken, exploiting underwater images, satellite images, webcams, and so on and so forth for very different use cases. And there are providers that provide resources for those use cases. So the point is, on the one hand, we have the platform that will be offered through the European Open Science Cloud for EU researchers and obviously related associated countries like Switzerland, UK, Turkey, and so on. And then we are also delivering the software so that somebody with enough resources can deploy their very own tailored platform for their needs.
I see. And so then this is it Image or Imagine a platform? You mentioned that they're doing something similar to that right now by using your software.
Yes.
I see. Great. How many scientists are using what you presented today right now?
The current setup, I would say it's been exploited by around 50 scientists that are, as I said, they are part of the use cases, part developers of the platform that are also doing data science, and some other, let's say, well, not use cases from the project, but since our institution, for example, CSIC, is really large, we are more than 120 institutes in Spain, we are gathering different users and offering the platform internally for them. Imagine, I think it will be also around 50 scientists at this moment using it for specific use cases. But obviously, when we open it through the European Open Science Cloud, we expect that the number explodes. The previous platform that we are building on, which was called the Deep platform, when we took the baton of the software and the platform deployment and so on, was serving around 100 scientists.
Well, I mean, 50 is a big beta trial, really, when you're trying to build a piece of software and understand how it's going to be used and so on. So that's quite impressive already. I guess the other type of questions that we received, if I just take a few of them, I guess, so this is with regards to the water quality study. One question that came in was, does this particular scenario expose some areas of federated learning research that need to be done? So I guess they're talking about some problems that would be more in the domain of how you do federated learning, where there's sort of new problems, or maybe some things that were very difficult that the scenario required. that then maybe some of the computer science, federated learning specific researchers might go away and try to solve?
Yeah, in this case, we decide to apply the federated learning to this kind of data, which do not present, obviously, any privacy restriction and so on, because maybe we can encounter different technical restrictions. And in order to test if we have some computing capability in the centers in which we are collecting the data, maybe we can perform this training without centralizing the data. And why are we interested in doing this without centralizing is just because we have tested that in some cases, as we have already saw, the federated learning approach performs better than the centralized one. And that was the reason to try to test if in this case it makes sense to apply federated learning. Maybe we could have encountered that the centralized approach works better for this case, but it wasn't. We find that the federated learning performs better in some cases, had better generalization ability in this specific use case. So that's quite interesting in order to be able to know that maybe if we have the computing capacity of the sensors, of the devices that we use in the different water bodies to collect the data, we could perform this kind of training as it is. An individual approach, which could be feasible if we have such computing resources, and we will avoid the problems of centralizing the data problems. I talk about problems of connectivity and so on. In some cases, as Álvaro has said, we need a lot of years of taking measures of the sensors in order to build a large data set. So that's why performing it federated could perform better, because we get more data, let's say, from different points, but more data.
I see. Interesting. Along the same lines, there was a question about could you explain a result that would have not been possible without the federated learning? Maybe this could be a result, I suppose, that maybe you haven't got to yet, but within this water quality application, the fact that you're federating it as an approach, did that allow you to do something that you couldn't otherwise do? I guess that's kind of what they're getting at.
Here I have one answer that, well, I don't know if it is an answer or if it is a guess. But for example, in this area, at least in Spain, but I guess this is mostly worldwide, there is an important point in water treatment plants, because right now there will be a change in the EU directives for wastewater treatment plants, so that the values of some compounds will be much lower, and therefore there will be a need for the companies that are managing these plants to let's say monitor these values more closely. But there are no sensors to do so. Either the sensors do not exist and you have to grab the sample and go to the laboratory, or either the sensor is too expensive and too fragile, meaning that it requires a lot of maintenance, and if the maintenance is not done properly, it will give you weight values. So having a system that allows you to monitor these values, obviously using as a proxy some other variables like a machine learning system, this can give you an idea of how the whole system is performing, and then you can do the manual measures of those values by getting a sample and going to a lab. But this is feasible in theory, okay? But the problem that we have is data again. In order to train a model, you need a lot of data, and sometimes those data do not exist at all because those companies were not collecting it or were not monitoring it properly. Mm-hmm. And the second point is that, at least for example in Spain, we have a lot of companies managing different wastewater treatment plants in each region, in each county, in each city. And obviously, these are commercial companies, and they are not willing to share the data. If we could join all the data that these companies are gathering, and we could build a large data set, maybe we could apply a model. I mean, not for the whole country, because it is very complicated, different conditions, cities, and so on. But maybe for specific areas, we could build, let's say, a global model in order to make these inferences, or at least a robust model. But obviously, these companies are not willing to cooperate and give you the data, because these are their insights on the processes of these wastewater treatment plants. So if we could convince them to join a federated learning experiment by just providing, but not providing the data, but just joining the experiment so that we can build this global model, maybe we could tackle this problem that does not yet exist, but will exist in the near future, probably.
You know, I can see. Yeah, I mean, I like the fact that this sort of parallels a lot of discussions that we see in healthcare, for example, but in a completely new domain that I think is equally important.
Yes,
but you really
indeed.
are
I mean,
sort of understudied.
In health, in the end, you have the data privacy from the, let's say, patient's perspective. Here, it is data. I mean, there is data privacy, but from the company perspective, that they don't want to give the individual samplings, because, for example, I don't know, you can get insights on how the wastewater treatment plant is doing one process or another. So there is a lot of parallelism here.
Final quick question would be just, are there any exciting other papers coming up in other domains? You mentioned that there are some other use cases. So I couldn't help but wonder if there is other type of research you wanted to kind of just mention being done already using this platform.
Judith, maybe you can comment on the agrometeorological case.
Yeah, we're working on applying federated learning to an agrometeorological case in which we have radar images capturing different. We are simulating different areas because we only have one radar, and we are splitting the radar images into areas covering different areas of a same country. So we want to apply this federated learning architecture to such data. And other paper that we published, I don't know if it was 1 year ago, I think, was covering the health field, in which we apply federated learning to a use case in which we have X-ray images in order to predict if a patient presents or not pneumonia. So in that case, we were simulating that we have different hospitals. And in the same line, that's another plan that we have for the future, but it's quite difficult to find data. We want to collaborate with different hospitals in our region in order to perform a federated learning training using medical data that they have regarding different topics, for example, cancer and other topics, and to perform such federated training with images, with medical images, capturing the different hospitals. Then we can encounter other problems in that field because of the machines that are used to capture the medical images and so on, but that are other issues. And I think that there are quite different fields in which we can apply this kind of learning approach. I'm going to mention one last one, which is inside the scope of the AI for US project. We have an internal use case, which is about thermography. So we are capturing images using drones in different cities of Germany. So the idea is to the future, when they have all the data captured, they are already developing the models. We want to perform the federated learning approach, in which one client will be regarding the images captured in one city, and the other's clients will correspond to images captured in other cities. So that's other application that maybe we could be carrying out within the scope of this platform, of this project.
Wow, there's some really interesting scenarios. That's very cool. Well, thank you so much, you both of you, for presenting today and describing your really impactful work. This is really exciting stuff. So thank you so much today.
Thank you very much.
So I have
Thank you, Nick.
one final. Oh, thank you. I have one final slide to show, and that is our final slide for today. And that is just our usual wrap-up slide. This has been Flower Monthly January. It's our first Flower Monthly of the year, and it's been, really a cracker of a start to the year. Two really great talks on sort of interestingly related topics, more related than I first imagined, because essentially both groups have built purpose-built platforms on top of Flower for simplifying the use of federated learning and the access to distributed data. So it's really interesting to see how that can be used. For example, in the first setting, we had García University talking about how their FedOps platform can be used as an example in healthcare, but other sort of scenarios too, where you want to use mobile devices and the web to simplify access to this technology. And then we had a second platform presented that was for scientists, where the sort of motivating application was water quality, but obviously the breadth of applications was much wider than that. So thank you both. Thanks both teams for coming today and showing what they're building using Flower. Our next Flower Monthly will be in February. As always, it'll be the first Wednesday of the month, which turns out to be February 7th. We'll have it at our usual time of 1600 UTC. If you want to give us feedback or discuss further, we have a specialized channel called Flower Monthly on our Slack workspace. There is also a Flower events calendar if you want to kind of be aware of the Flower Monthly events, as well as any other events that we have scheduled, such as the Flower Summit in March. Please feel free to join. And then if you want to see the recordings of this event, which actually is where we get most of the views, you can go to our YouTube channel or go to the flower.dev website, where we have a page for Flower Monthly, and you can see all the recordings there as they appear. That's it. That's it for today. Thank you all for joining, and I'll see you next month.
Thank you.
Thank you.
Bye.
Thank you very much.
Thank you, and bye-bye.